Okay, Mark, you've just confirmed you can only see Daikin.
Yes, I can only see Daikin.
Oh, good, thanks a lot. Right. Good afternoon all. Welcome to our third and last session of VRV installation training. My name is Glenn Bradshaw. I'm product responsible for VRV with Daikin South Africa. And I'm going to be taking you through the last section this afternoon. Just up front before we get going, if I could just ask if you could all please mute your microphones and keep your cameras off throughout the time that I'm presenting. I will be stopping periodically to take questions. And Mark will also be watching the box just for a short while this afternoon. So I'll also pick up a couple of the questions if you happen to drop them into the chat at the end. All right, okay, so let's get going. So if you could just please ensure that microphones and cameras are turned off so we don't get any background feedback. All right, so we started off with session 1 and we've done session 2. And the one thing that I drove home right from the beginning was that any successful project planning is essential. If you fail to plan, then you might as well plan to fail. And I asked the question last week, how much planning have you done? I'll ask it again, how much planning have you done this week for this week's work? Or what have you done today for this week's work? Okay. Also, something else to consider when you're working on site, you're the last person there. So therefore, make sure that you autograph that installation with your excellence. So basically, there was a saying there, and it said, every job is a self-portrait of a person who does it. Autograph your work with excellence unknown. And then, of course, today, just something with a bit light-hearted, and that is commissioning. And the one thing that we all hate to see. Just something there. All right, so shall we begin? Okay, so we're doing commissioning this afternoon. We're going to talk about the steps required towards the end of an installation to get it ready for commissioning. And often we find that this is one of the areas where the job falls down because of a lack of planning, once again. All right, so how can Daikin help? All right, so Daikin's got a number of ways in which we try to assist you in getting the installation right and getting to a point where it becomes commissioned as a successful project that you can hand over and obviously get paid for. The ways we do this, we do Daikin Academy training, which this forms part of. It's the online training. Okay. We also do Daikin site inspections, the bookings, pre-commissioning checklists that we issue, and also you can book a Daikin VRV commissioning. So what are some of these services that we can look at? Let's just break them down. The Daikin Academy training, we have 2 methods, practically based classroom training at our centers in Cape Town, Durban and Joburg. And by request, we can do for East London and Port Elizabeth as well. We also do online training, and this forms part of that, what we're doing this afternoon. And this, whatever we're doing this afternoon, is recorded and is then pushed through to our Daikin YouTube channel. If you haven't subscribed on this channel yet, please go through, find it. It's Daikin South Africa YouTube. Subscribe on that channel. You'll see a number of videos that have been added to it. Along with that is the first 2 training sessions and some other training sessions that we've done as well, along with some fault finding videos. And that database will hopefully start growing in the future. Daikin site inspection bookings. Okay, well, you can book an installation site inspection, which is a good idea. If you're not too sure of what you're doing, contact our service coordination at daikin.co.za with a good time frame and ask us to carry out an inspection while you're on site doing an installation. We can go through it, and we do carry out a little bit of on-site training with this in a way just to go and get confidence and knowledge up to a good level as well. We also offer a service where you can request a quote for a call-out assistance or existing site assessment. These are normally done on sites that are currently operational. Okay, and yeah, change my, yep, okay, and you can use that service coordination at daikin.co.za. Right, the other method that we use, okay, well, we issue a pre-commissioning checklist, okay. And the way that we designed this checklist is obviously it'll give you some guidelines through which you have to do certain things by certain days before a commissioning takes place. And then there's a checklist. And the checklist is something that you can use as a project planner. Basically, the things that are inside the installation manual are also listed here, and you can go through and you can start ticking things off. So it's not a bad thing that a technician who's doing an installation should actually have this document from day one of his installation, so he can start seeing whether he's making progress in terms of getting the commissioning done. Okay, so once he's completed that checklist, it forms part of the requirements. Okay, and that's the next part. Book a Daikin VRV commissioning. How do you go about doing that? Once again, it's the email that's servicecoordination@daikin.co.za. The lady manning that desk, operating that desk, she will send an email out, and she will give, on there will be a number of items that need to be completed before we do a Daikin VRV commissioning. Okay, these include site schematics that are filled in with as-built piping lengths. These need to be given to the sales engineer for final sign-off, and also they will then give us the additional gas charges that the computer calculates on there. We also ask that you complete the pre-commissioning check sheet, which I've just spoken about before this. You forward an order number for the commissioning works, that all air balancing is complete. It's also on the document for pre-commissioning, and I'm going to talk a lot about that later on. Should the installation consist of hybrid units, you need to have a representative from that air handling units manufacturer. They must be present. Okay, and we will sometimes request that you send through images of the condenser installation so that we can just make sure that there's no problems in terms of the piping. Remember, we spoke last week in depth about the piping around the condenser when you're installing it. Okay, and then also please ensure that you give us a site address so that we know where to find you. All right, so let's begin this afternoon and have a look at what happens with commissioning on site. Remember that Daikin reserves the right to commission all VRV equipment. Okay. Once we commission equipment, the warranty falls into place if we're satisfied with the installation and that there's nothing that needs to be changed. And so we will arrive on site. And these are the steps that we're going to go through, but we want to bring you up to speed with the steps so that you understand what we're going to be doing on site. Okay. Right, so the first thing is that we need to know the trim charge, the additional refrigerant that is added to a system. Remember, the condensers are factory charged, but this charge is only for the condenser. It does not take into account the additional amount of refrigerant that is required for the piping that you install to the indoor units. Sorry, can I ask if you turn your microphone off? Thank you. Thank you. Okay. The trim charge, okay, well, the additional amount of refrigerant, okay. We're also going to look at trim methods, trim charge methods, okay, and respect temperature limitations on there. All right, so in calculating, probably familiar, you've seen a formula like that somewhere in the installation book when you were reading it, okay, and you wonder what it's about. Well, basically, in order to calculate the refrigerant charge, we need to go through a number of steps to make sure that it is correct. First of all, we need to know the sum of the liquid line pipes for each pipe diameter. Okay, so we don't want a total length of just given to us 150 meters of liquid line. We need to know the length per diameter. So much half-inch piping, so much 3/8 piping, so much 1/4-inch piping, for instance. That's what's required in the calculation. Each of these dimensions, okay, is then multiplied against a factor. Okay, so here you see diameter 22.2. This would be 7/8 inch liquid line, and that is multiplied with a factor in there. Okay, and the factor is inside the installation manual. Once we calculate it by that factor, okay, it will then give us an amount in kgs of refrigerant. The next step is it may ask us, okay, now there are different formulas for different condenser units. So this example is taking us through a heat pump system. Okay, so basically we're looking at factor A, and on this one over here, it tells us that an additional amount would have to be added per condenser, or may be required to be added depending on the connection ratio. Okay, first of all, if the total pipe length was less than 30 meters, okay, then we see that some of the condensers would not need any additional amount added if they fell within these capacity ratio percentages. But for some of them, if they were to exceed these or fall into these categories, we would have to add this amount per a condenser, okay, that fell within those horsepower ranges. All right, so the calculation gets a little bit more complex from there. All right, then you may also see on the calculation sheet an amount for a unit RYYQ. Ignore this amount because we don't bring these units into the country. Okay. And then, of course, there's an amount that is based on the number of indoor units. Once all of this is calculated together, we get a total amount of kgs, okay, that were required to be able to add to the unit on top of the factory charge. Okay, so you'll see a sticker. The sticker will ask you that we supply. You will tally up the amount of refrigerant per the factory charges, and then there's an amount on there for the additional gas. All right, so now that you understand how that is done, the most important thing that is required from you guys when you're installing is that you know the amount of liquid line lengths per diameter of piping that you've got. Okay, without that, we cannot even begin the calculation. So that is critical. So it's very important. And remember, right back in the planning stages of our installation, I said to you guys, when you've got a schematic diagram, okay, work on that schematic and daily update the lengths of piping on it. Don't try and do it at the end when people have closed up the ceiling and now you've got to do a whole lot of guesswork. All right. It's critical that we get the exact amount, regardless, okay, of which of the trim methods you're going to use when charging up the system. All right. Okay. So let's have a look at those trim methods. Okay. So remember, we said that you would pull the vacuum on the system. That vacuum would have been pulled down to below 500 microns. We would have then done a vacuum decay test. Okay, and with that vacuum decay test, if it passed that, it was a 100 micron climb in less than an hour, no more than that. Okay, and if it's a lot less, then well done. Then we break the vacuum with some R410A. Okay, we'll break it with the amount, with the required amount that's calculated from the formula that we've just been working with. Okay, and we'll charge it into the liquid line, and then we will open the valves. Okay, right. So let me just go back on that. Breaking the vacuum of 410A. If the charge is less than 5 kgs, we will tend to charge the full amount. Okay. If it's greater than 5 kgs, then we will look at doing a manual charge. Okay, or an auto judgment charging. But we'll always break it with some of the refrigerant. Okay, just to make sure that we don't suck any air into the system. Okay, so moving on to that, manual and auto charge judgment. Okay, the compressor operation will reach a target evaporating pressure equivalent of -15 degrees. Okay, and always charge to the charge port. Now remember, we showed you in the images, okay, that there's a charge port, not through the service valves, but to the right of them. Okay, and then through that charge port is the only way that you can charge. Okay, never ever exceed the calculated amount of refrigerant, no matter what method you are using for manual or auto charge. And it's very critical that you have keep an eye on this. And this is why you cannot arrive on site, okay, and do an auto charge without knowing the actual field piping lengths and having done the calculation. Okay, and I've seen where systems have been put onto auto charge, how wrong it can go. Okay, and how it is easy to see how a system can overcharge itself through some factor that happened during the course of the charging. Okay, and this can be from an incomplete installation where discharge air was being blown from diffusers directly into the return air because ceilings hadn't been installed yet. Okay, right the way through to a glitch where electricians turned off power to an indoor unit during the auto charge function, and before the system knew it, it had become so confused, and it was something that was picked up much later in there. So it is very, very critical to always know what the actual amount of refrigerant required is before you do any of these methods. Okay, how do we go about doing them? Okay, so for the manual charge, basically there's a procedure which we go in and we use mode 220. All right, and this little video clip, which I'm coming up on now, will take you through that. Yeah, so basically, yeah. So the video there seems to glitch a bit, but 220 is basically like putting it into the mode 221. Okay, but you're just using mode 220. And over here it tells you that you only open the valves when it shows TO2. Now you'll see it flashes back and forth between TO2 and a value. There you see 0.96. That is actually the suction pressure. Okay. And it's actually 960 kPa. Right, so it's showing you that in megapascals. All right, so when you see us doing this, a lot of times the technicians on site will ask us, why does it flash back and forth? It's actually giving us a suction pressure while we are charging the system. All right. Okay, auto charge, again, auto charge has got a procedure, and show you that. That's tier 1, two. That's tier 3 starts flashing. Well, all right, so just to try and take you through what is happening in the system while it's charging. Okay, if you're familiar with the pressure enthalpy diagram, there are 3 critical points for our air conditioning system that we need to keep an eye on. Okay, and these are the suction superheat, which we find down here. Okay, this is when the refrigerant starts moving into the gaseous phase over here. Discharge superheat, which is critical, which we find at the top. Okay, and then our subcooling. Now you'll see that if we only open the valves on the system and didn't add any refrigerant, the system would run undercharged, and this would bring the subcooling into a position, okay, where there would be flash gas. Okay, so basically we need to bring the subcooling through to where it is liquid. So if we have flash gas, we have a capacity drop, and we have additional refrigerant noise because we've got bubbles in the system. Okay, so those traveling through the piping will tend to make noise. Just something to consider. Okay, should you be 10% undercharged on a refrigeration system, on an air conditioning system, you could be 25% short of capacity, and your system may draw 33% more power in order to try and achieve its operating or its design condition. Okay, so it's very critical that we actually get the refrigeration charge correct. And so again, you guys do need to measure the piping accurately. That's not step it out, measure it with a tape measure. Okay, all right. So when the system is charging like this, what it's basically attempting to do is, as the refrigerant goes into the system, okay, it moves the pressure enthalpy diagram as the refrigerant goes in, and we see some subcooling taking place. We still got superheat, and we still got suction superheat, and we still got discharge superheat. Okay, and you can see it's critical that we get subcooling. Okay, and I always remember as an apprentice, my journeyman used to push it home that you have to have good quality liquid in order for a refrigeration system to operate, and that's the part of our air conditioning system that we need to concentrate on. The quality of your liquid is critical, and that is what the system is looking at while charging. Okay, so basically the outdoor unit will may need to decide the optimal subcooling. The indoor unit will check superheat, and the type of outdoor may need to judge a total refrigerant weight. Conditions before you can trim charge. Now, obviously, these trim charges cannot just be cannot be done under all conditions. So we need to know what sort of conditions are required in order for them to happen. So basically, the outdoor condition, this dot on the outside of the house, tells us that the outdoor conditions must be greater than 0 degrees Celsius and must be less than or equal to 43 degrees Celsius. When the outdoor conditions are outside of these parameters, you may get a fault E3. The next parameter that we need to keep our eye on are indoor parameters. And these are, you must be greater than or equal to 10 degrees Celsius, okay, and less than or equal to 32 degrees Celsius. Right, so today in Cape Town, yeah, it's pretty chilly here. I'd say we're probably close to about 12 or so, where I am at the moment. The other thing that needs to be satisfied, because obviously, sorry, if you don't get these over here, you'll get an E2 fault. Capacity ratio must be greater than or equal to 80% and less than or equal to 130, okay? And it must only be done with VRV indoor units. In other words, if we have got a combination on the system of hybrid air handling units, hydro boxes, or RA units, then you cannot do an auto charge for those systems, all right? Then it is critical that you do the manual charge, and that is through adding the gas manually into the system. All right. So keep your mind on those things over there. We've ended the first part of this afternoon session. Are there any questions before we carry on? Okay. Is everybody there?
Yes.
Yeah.
Yeah, great. Thanks a lot.
Yes, yeah.
Okay, thanks. Always difficult doing online presenting. We never know if you're still there. Right. So we go on to the next section. And this is the test run. Okay, so starting the unit. Okay, these are the things that, again, it's critical that we get everything right. For instance, on the test run, okay, here's a little scenario. VRV easy startup finished within an hour. Test run made all at the same time. This is 3 systems, and the service engineer boasted that he had all of them up and running within an hour. He ran them all together. A couple of weeks later, he gets sent back to site, and he's experienced a compressor failure. All right, what do you think went wrong? I'm going to ask you guys while you go out there. In a system like this, where there's 3 systems and you try to run them all up together, what could go wrong?
Yeah, these gas pipes swapped around.
Yeah, gas pipes swapped around. Yep, good chance that he swapped these refrigerant pipes around. You're right. Okay, what else can be swapped around between these systems?
Wiring.
Wiring as well. Okay. So it's never a good idea on commissioning to try run more than one system at a time. Okay. It's also very important that the service engineer, okay, will keep his eye on a system and monitor the operating parameters one at a time. Okay. And yep, if you've been pushed into a rush and you try and do this, it's very, very easy. And I've seen this happen not just with VRV systems. This has happened on sites where there's multiple splits and there's been piping swapped around and the guy turned everything on together and try to commission it like that. And lo and behold, a few weeks later, a few months later, there's dead compressors and everybody's saying, oh, this product's soft. And it actually turns out that we've got piping swapped around, and so it causes compressor failures. All right, so what happens in the test run, the logic, you guys often ask us the questions, so let's go through it and have a look. Okay, so the test run logic, basically you'll see that the systems of VRV4 start out at TO1 and they run through to T10. So TO1 is a pressure equalization. Okay, outdoor fan goes to step 4, which is medium speed. Indoor fan goes to high speed, and they check indoor air coil temperatures the air minus coil temperature less than 5 degrees. Okay, then the startup. Okay, increase compressor RPM, HP minus LP. Okay, is greater than the set. So basically it's saying that there must be a difference between the HP and LP pressures as it starts up. All right, TO3 is a cooling stable condition. And here it tries to reach the target evaporating temperature of minus 15 degrees, okay, which is set by the main PC board in the unit. Then TO4 is a communication check. Okay, there we see indoor goes to low speed. Okay, the outdoor temperature and the coil step 1 to 4, and it must see a greater than 10-degree drop, which we would expect as long as there's no blockages in the pipe. Okay, and it's also, this is essential. This is why it's essential to only run one system at a time, because if you've got more than one system running, they can all give that variance of 10-degree drop, and then the systems will never know whether they've got any swap piping. Okay, TO5 is a stop valve check. Okay, the hot gas bypass will close, and LP drop limit. TO6 is a pipe length check. Over here, it's learning the pressure drop of the system. Okay, so this, we always tell the guys it's a learning cycle. Okay, and it's at a 6-degree target on there. TO7, the refrigerant amount check. This is to see whether there's an overcharge or wet operation. How do you check the operation of the wet operation, or where it's slugging liquid? There's another term that you might hear. Basically, it looks at the discharge temperature, and that discharge temperature, if it falls below a certain value, will indicate that there's liquid coming back onto the compressor. Okay, so just remember, high discharge temperatures normally indicate an undercharge. Low discharge temperatures or temperature differences would indicate that we have an overcharge condition, okay, or liquid floodback as well. Refrigerant amount weight, okay, this is TO8. Calculate the circulation of the 410 refrigerant. TO9 is a pump down operation, basically close expansion valves on the indoor unit, and T10 is the end, and this normally will display for about plus minus 2 minutes due to a guard timer, and then we'll go off. Once these have all been satisfied during a test run, the system has completed the test, okay, and we can now do an operational test. And this is the critical part that we are interested in. This is where we can start to do testing of whether the units are performing, okay, as designed. All right, and on heat recovery machines, we will do 1 or 2 mixed tests, but we cannot always do all the units. If you've got 20 odd units, we cannot do a combination of all of them to see whether you've got swap piping and cables coming off your BS boxes. So we'll do 1 or 2. And then after that, if we don't pick up anything, we'll clear it. But that means that if there is a problem, it comes down to the installation. We don't have the time to sit and do all of these combinations. Okay, so it's very important, again, back to the installation phase, that everything is marked during the time of installation, that like port A is connected with wiring A to unit A. Okay, all right. Monitoring tools during the test run. Okay, so let's have a look. Different monitoring tools that are available. The first type is the Service Checker 3. This is the older of the service checkers. And then we have the Service Checker 4, which you'll see a lot of the Daikin technicians now carry with them, a smaller box. Yeah, but easier to operate as well. Just remember that these devices connect to the F1, F2, D3 network. Okay, and they connect on the F1, F2 outdoor. Okay, then we have some devices that are available, okay, to the installers. Okay, this is the D checker. D checker requires a laptop, okay, and this plugs into the X27A connector, okay, on the A1P board. All right, we also have the Daikin monitoring tool. Okay, and this is a Bluetooth device. Okay, this also plugs in onto the X27A device. Then in the future, we're looking towards a service diagnostic tool. Okay. And this over here would also help in terms of determining what faults might be on the system. Okay, it's under development. Okay, right, so what is not a checker or a de-checker or a monitoring tool. It's not a crystal ball that we plug onto a system, okay, and it automatically jumps up and says, you have a fault, you have swap piping, or you have swap wiring. There is a tool that gives us information and data, and from that we have to diagnose. So we have a lot of guys who are asking, okay, well, when can we buy this? Okay, well, first of all, the checker tools are not for sale, okay, but the de-checker and monitoring tool are. But when you purchase these, you must realize that you're getting information from a machine. You still need to make a call on that information. So it's very important that you actually understand how the system operates, all right, so that you're able to discern that information into some sort of fault report. Okay, right. So, as I said, the two checker types work on the F1, F2. Okay, the de-checker and mobile monitoring tool. Okay, those connect to the PC board. Okay, and when the service diagnostic tool arrives one day, that will be, you can make a choice as to where you want to connect that. Okay, so basically, as I said, F1, F2 on the outdoor unit. All right, so it connects on those ports over there. Okay, and on the indoor wiring over there. Okay, generally you can only connect it to the last unit on a heat recovery machine or the last BS box. I find otherwise that sometimes you don't get so lucky with connecting. Okay, so there's the connection type. Okay, diagram of how it goes together. Okay, pretty simple. Okay, obviously this device also, the checkers connect onto a laptop, so we're able to read the information. Okay. And over here you'll see the de-checker plugs onto the X27A of the outdoor PC board, and that plug is found in this region just below and to the right of the segment display. Okay, so as I said, de-checker and mobile monitoring tool are available to installers, okay, and can be used as a fault finding tool. You can make recordings from these tools, and you can send those recordings to us, and then from there we can also help you to try and discern where your problems might be. All right, so what are we looking at when we have these tools connected? A couple of things that need to be monitored. Okay, discharge superheat, okay, needs to be between 25 and 45 degrees Celsius. Okay, so what is that? Discharge temperature minus the condensation, the saturated condensation temperature. So that's the temperature that's read from the pressure that you would get off, say, a gauge manifold. Okay, and you subtract that from the actual discharge pipe temperature on the leaving side of the compressor, on the discharge side of the compressor. Okay, and we're looking for a 25 to 45 degree difference in there. Suction superheat, so the header temperature minus the temperature of evaporation, or that we measure on the suction gas side of our manifold, and the target superheat, okay, is set to 5K, but suction superheat can be set lower if the difference between the air and the set point is high, okay, or the discharge superheat outdoor is high, okay, over 45 degrees. All right, then it will try and set down the suction superheat. Okay, suction superheat can be set higher if the difference between the air temperature and the set point is low. Okay, so basically here we're increasing the suction superheat, or the discharge superheat outdoor is low, below 20 degrees. Right. Cooling, again, we come back to looking at our liquid temperature, and here we're looking for a stable operation to reach a target or factory set amount of 6 degrees, okay, and a difference in temperature between the coil and the target evaporating maximum 8 degrees. Okay, so this is on the indoor. Here, superheats is the gas minus the coil, an initial 5K. It's possible to go up or down depending on the air minus the set point value. Okay, and we just discussed that now. The expansion valve control in cooling, okay, is normally between 400 and 1,200 pulses. All right, it is possible to see it come down if there's less load, and the gas temperature normally between 3 and 10 K, greater than the coil temperature. Okay, right. So on heating, the coil temperature generally tries to reach a temperature of plus minus 38 degrees, and the expansion valve is open if the set point and minus the air is greater, because it's targeting the subcool. Remember, we're looking at now the indoor unit is now behaving as the condenser. So the subcool values are set from there, and it'll close if the set point minus the air is less than, because the target subcool is greater. Okay, and then minimum requirement HP minus the head pressure minus the liquid pressure, and this is to ensure that there's sufficient flow of liquid taking place. Okay. All right, so we've got to the end of that. Are there any questions? Okay, very quiet this afternoon. Shall we carry on? Test run trouble. Yeah, so often on startup, if there's any problems, we'll run into these errors, and we'll need to resolve them during the commissioning. Okay. So let's have a look at what sort of happens. Ever come across that on a VRV4 condenser? What does it mean? Yep. It means that the manual leak check function was performed within the required temperature limitations. Yeah. So right, test run troubles. So let's have a look at the error code buildup. Okay, so this is where this course starts to fit into the advanced VRV fault finding. Okay, so now we've got an overlap between that and this course, so it's important that the installation technicians also get to know a bit about this. Often there's a difference between a service technician and an installation technician. Okay, but it's always important that the installers also have a fair idea of how the fault codes are built up. All right, so many of you might be familiar with the old Daikin cardboard fault finding chart that we used to give out at training. Okay, nothing's changed. It's still applicable if you've got one. You can download it as well on the internet. Okay, and then we've also got a number of apps which I spoke about earlier on in the training, which can also help you fathom out your way through here. But just to understand a few things about the error code and the way they're built up. The one thing that Daikin's been pretty solid with over the years, I've been with the product as an engineer and as a Daikin employee now for more than 30 years, 9 years with Daikin, and I can tell you now that the fault codes have been pretty constant. ANC, any code starting with ANC will designate an indoor fault. Okay, and then they range through from 0 through to 9, and then with A, C, E, F, H, and J. Okay, on there. So anytime you get an error code that starts with an A or a C, you need to be heading towards the indoor unit in order to fault find. Okay, the upper digit. Okay, if it falls E, F, H, J, L, and P, you see these, any error code beginning with these, you need to start heading towards the outdoor unit. And there's a list of outdoor units, fault codes over there. And again, following the same thing. So if you see codes F3, okay, this is malfunction of discharge pipe temperature. Okay, it says malfunction. Now you've got to be careful how you read. Very often when technicians see a fault, they tend to think that the component is faulty. No. Okay, what is very often happening is it's telling you that that component has sensed an abnormality in the system's operation. So the first thing you need to do, yes, confirm that the component is working properly. Okay, if it is, then the information it gave you is related to the operation of the system. Okay, so don't just keep trying to replace parts. Remember that each of these error codes is pointing you in a direction to try and fault find the system. All right, so yes, it could be a faulty component. very often when it isn't a faulty component, then you need to start doing the legwork as to identifying what in the system was abnormal in its operation. All right, so the type of thing, we've got a high discharge temperature with F3. This could be from a shortage of refrigerant. Okay, with high discharge superheat. Remember, we spoke about it just now. That type of thing, we're going to see if we're not getting enough suction cooling back on the compressor. All right, so just always think about that. When you see error codes, don't think in terms of parts replacement only. Think in terms of actually resolving an abnormal operation of the system. Okay, so there we have a J3. Here's a malfunction of a discharge pipe thermistor. Over here, the thermistor is moved outside of the parameters. Okay, and there we see system on the error buildup with VRV4. We didn't just get a J3 error, we start to see some additional codes along with it. And these codes will point us in direction. So here we see a J324 is a discharge temperature sensor malfunction of an R22T, and it says it's open circuit. If it's open circuit, what it's telling us is the thermistor is giving an open circuit reading back to the PC board. This could be the thermistor's faulty, or possibly the PC board might be faulty. And a -24, or the 24, tells us to look at the slave 1. So here it's making life easy for you. You see the J3, you don't need to look at the master or slave 2, you need to go to the slave 1 condenser. Yeah. Right, here's something that you need to also keep in mind about slave 1 and slave 2. If you're standing next to a configuration of 3 condensers with a master, slave 1 and slave 2, the slave 1 is actually not the condenser that is next to the master. It's actually the furthest condenser away. Okay, so just keep that in mind when you're fault finding as well. Okay, so just remember that on VRV4, you now get an additional code along with the code that was originally on the old error sheet. Okay, so the malfunction sheet there, it now helps you in pinning down the error to the correct condenser in multi installations. Okay, error code retrieval. Okay, you can get these from the remote controller on BRC type controllers. Okay, you can get it from a central control device, from an ITM. Okay, from a service monitoring device. We've discussed those devices just now, a couple of minutes ago. From the outdoor PC board, from a symptom description. All right, so from a remote controller, the fault, the unit stops operation. On outdoor unit, system stops. In indoor, other units keep running except if the system is U4, U9, UA, UH, or A9. An operation LED on the remote blinks. Okay, we're talking about the operation LED on the remote. Okay, not that little green happy light that's flashing on the PC board. Okay, caution, only error code is shown, but the unit keeps running. These are for outdoor UO, L2, F6, and the indoor unit AF and A7. BRC 1A, B, C, and D have the ability with code 40 to keep the last 9 error codes. Okay, BRC1E has a service setting. Okay, that one over there, you'll find it under the error history. Okay, and then on the BRC1H, the Madoka app, this is the one that connects to a smartphone, you need to tap the 0 button in the middle of the screen at the bottom. You can get it from a central device like an iTouch controller or iTouch manager. The indoor units report the error code for both indoor and outdoor to this device. Okay, from a service monitoring tool, these are the devices we spoke about earlier on, the service checker, the monitoring tool, and the D checker. Okay, these give an error code indication and a list of parameters, and the subcodes are not available. Okay, and mostly error code only displayed for limited time. In monitoring mode, error codes stopping unit code 17, 18, and 19, and an error code minimum 1 for an automatic retry. Okay, so what's going on over here? You can get these error codes from the outdoor unit, okay, in the monitoring mode, okay, and these are using codes 1, 17, 18, and 19 for error codes, and then error codes for the automatic retries. So you can actually see whether your system is going through retries, and you can pick those up from codes 23, 24, and 25. These are very important if you get to a site, especially the 17, 18, 19, to use them if you've never been on a site before. They will give you an idea of what's been going on the site and give you something to start working with. It's kind of like a bit of CSI. You don't have to start from scratch looking at these, and especially if you also pick up the error codes out of the remote controllers that are inside the memory. Use those as well, especially when you've picked up a site that you've maybe somebody else has been thrown off of before you carry on. Just have a look at what's been going on. Okay, symptom descriptions. That's basically the type of descriptions that you get from a call from an end user. Room not heating, the room aircon's noisy. Certain complaints are not considered as an abnormality. Remember that when a unit changes from heating to cooling, there will be a shushing noise as the gas changes through the four-way valve. There's nothing you can do about it. Okay, you also get that at the end of a defrost cycle. Okay, so keep those things in mind. You also need to be able to explain that type of thing to an end user as it's part of the system's operation. Okay, if the complaint is justifiable, then investigation of performance would be required. Okay, and yeah, you might need to use a service monitoring device, and advanced knowledge of the unit is also required. All right. Are there any questions?
No, no question.
Nothing from there. Okay, all right. Great, thank you. Okay, so the last session this afternoon, so the last part of this is the handover, the installation, and it's very critical that this is done properly. A lot of times when we get calls to our offices from end users, it's because something hadn't been explained to them correctly, okay, or hadn't been explained at all. So it's very important. It's part of customer relations as well, that when we hand over an installation, that we do it in a manner, okay, that the end user takes ownership of their plant and that they're happy with everything. All right, so my unit is not heating and the installer left without operation. Okay, indicate 2 reasons why the air conditioning unit is not working. And I'm asking you guys a question. Why do you think it's possible? Somebody says the unit's not heating and the installer left without an what could have happened?
The unit is set to low temperature. It's on heating, but the temperature is on 18.
Okay, all right, there you go. So you can see there. Okay, so he says it's not heating and the set point is set on 18 and the room temperature is 23. Correct. Okay. Are there any other reasons outside of what you've seen on that image that could be perceived as a problem by an end user, say in heating mode, since we're in winter? Okay. When a unit goes into heating, what happens first to the unit before we actually feel any heat? It's a question from me to you guys.
The fan blower goes off.
Sorry, go ahead.
The fan blower goes off.
Goes off, okay. And then what's happening inside the unit when that happens?
The gas flow will start flowing the moment the sensor, the inlet gas sensor senses the temperature of the refrigerant, then the blower will start running. The evaporator fan will start blowing. All
right, okay. All right, so I agree. Okay, so what's happening is that, first of all, the indoor fan will go off. Okay. What happens when that happens is that the compressor starts to pump hot gas through the indoor coil. Okay. And once that coil reaches a prescribed temperature, okay, only then does the fan come on, and this is cold draft prevention. Okay, so now this might be perceived by an end user as a problem. And I've had clients before call me and say, I put the unit on heating and the fan went off. And then only a while later did it come on. And I'm saying, yeah, the reason why it's doing that is to stop so that it doesn't blow cold air onto you. We warm the coil up and then we blow warm air onto you. Okay, so that's to help with your comfort. All right, so there are different ways, and if things aren't explained to an end user, then we could get calls that are generally because the end user doesn't understand the operation of the unit. Okay. All right. Okay, handover of the installation. Okay, if there are legal requirements, okay, then these must also be met. Okay, so what are legal requirements? I can issue a commissioning form. Okay, at the end of an installation, that commissioning sheet indicates whether commissioning was successful or not, and if there are any items that need to be attended to. And sometimes we'll say that once the items are attended to, then we will pass the commissioning as passed. Okay. On that form, we give a date, type of refrigerant, nominal quantity of refrigerant, okay, and quite a bit of other information as well. But this is also is not a legal document, okay, so it's our commissioning report, okay, to the company who has done the installation. All right? You need to have a look at your local legislation, okay, and if you're required to activate refrigerant leakage checks, then those should be adhered to as well. Okay, and all intervention that requires to recover refrigerant should also be documented and left on site. Okay, and also results of periodic refrigerant leak checks should be logged. Recommendations to avoid future similar problems, and the name, registration number, service person that made the intervention, okay, as well as the certificate to decommission of a unit before removal. That's when a unit has reached the end of its life cycle. So one of the things that's supposed to be kept on site with air conditioning installations is a logbook, which all calls are logged into. And if any work is done that required removal or addition of refrigerant, it should be logged in there along with those repairs. Okay, so it should have all the general information on there. Okay, and it could just be a basic table, something like that, with worksheet number, description interval, intervention, sorry, and the amount of refrigerant added or subtracted. Okay, all right. Unit should have the HFC sticker indicating the amount, the factory charge, the trim charge, and the total charge should be on every installation. Okay, this should also be placed in a position where it doesn't get damaged by the sun. Okay, we see a lot of stickers added to units, and within a couple of months, because of the sun, you can't read them any longer. So we recommend that when we add these stickers, we write in the amount of refrigerant. It's put in an area where it cannot be rubbed away. And also putting these things on a cover, just a word of advice. Remember that if there are multiple systems on a site, it is possible for covers to be swapped. Okay, so rather put it onto some fixed object in the unit that cannot be swapped, say between two condensers that are like. Okay, give an instruction card, which contact when in trouble, so the installer and service company. Also how to start and stop the AC. I've seen some companies that do some very nice laminated cards, which they stick above the controllers after handing over a unit. These are quite handy as well in terms of just getting the installer, or the end user, sorry, getting them started with using the units. Okay, and also how to stop the unit in the case of emergency. This is also a very important thing. I bet if you asked a lot of end users, if there was a fire on their unit, would they know where to turn it off on the DB board? Many of them would not be able to point that out. And those are the type of things that form part of the handover, is to take a person for a walk through a system, Handover is not something that you can do from the comfort of your desk. Okay, it's something that you actually need to walk the end user through. Right, and show them where the controllers are, how the controllers operate, where the indoor units are mounted, what is required of the indoor units in terms of maintenance. Okay, so filter cleaning, things like that. And if access was allowed for it, you can always point that out as well. Okay. And then also just where the electrical power supply is and where they can find the circuit breakers for the units as well. Okay. Examination of the efficiency of the operation of the unit. Okay. Interval depends on the total cooling capacity, and it's recommended for 12 to 50 kilowatts every 5 years, 50 to 250 kilowatts every 3 years, and over 250 kilowatts every 2 years. Now, going back to what I spoke about earlier on, Daikin can, if you want to, you can request a quotation from us to come out to a site, to couple up a service checker, to run the system through operation. Hopefully we can do heating and cooling depending on the outdoor conditions. And then what we do is we can give you a service report on that. We would also go through the indoor units, the outdoor units, and give an idea of possible maintenance issues that are on the units. You remember that electronic components, they don't last forever. They do have a life expectancy, and there comes a time when you may have to consider that thermistors are no longer in calibration, and you can always offer a client a thermistor replacement kit, and this would be advantage to the unit, because that information going back to the PC board, if the outer calibration is not accurate, so the unit will not perform as designed. So these are the things that can be replaced. Also remember that there are certain like inverter PC boards, especially as units start approaching that 10-15 year mark. Sometimes these can go faulty, and basically they just no longer drive the compressor. There's no sign of faults on them. They need to be replaced. They've realized the end of their life expectancy. Okay, and they generally would need to be required, so to be replaced, okay, as required on there. Okay, and this is something just to consider as well. Like I said, nothing lasts forever, and yeah, so just as a service function, and as we've said to the guys, you know, if you're doing this type of thing, you're in business to seek ways of keeping people's equipment running, and so this is one of the ways in which you guys can make some extra money if you're keeping an eye on this during the servicing, making sure that sensors and thermistors and things like that are in calibration and working effectively. Okay, certificate from the manufacturer on delivery of the equipment. Sometimes we have to give that. A logbook should be handed over. The HCF sticker should be put in place. Instruction card for operation. Registration on the storage and handling of refrigerant on site. I know that a lot of your bigger users of air conditioning are now required to keep a register which gives the total amount of specific refrigerants that they have on site. I know that I've worked with pharmaceutical companies where that is updated on a regular basis. And then the examination of efficiency of the operation of the air conditioning system, okay, which is part of the service function, and is something that you can obviously charge for as well. Okay, explanation to the customer, as I've been saying, explain the condition of the system, okay, operation method of the system, the period of maintenance, very, very important. Often when handing over a system, it's never explained to the client that he actually needs to service this equipment. And I've always bumped into people, and I say to the guy, well, you drive your vehicle, and how often do you service that? And the guy says, yeah, every 10 or 15,000 kilometers, depending on the manufacturer's specifications. And I said to him, well, if you were driving your vehicle as often as you use your air conditioning unit, and you were doing an average of 80 kilometers an hour, how often would you be servicing it? Okay, now remembering that our air conditioning systems are a lot more efficient than motor vehicles, okay, it starts to give a person an idea that they need to start thinking about the maintenance of an air conditioning system. Also, poorly maintained systems break down, okay, and often they break down in catastrophic events which require major components to be replaced at high cost to the end user. Okay, and nobody likes to part with their money. Right, so if people just maintain the equipment, then we would be able to avoid a lot of these breakdowns. Contact point for any problem. Okay, and this is a very important thing to hand over. We don't want the end user going to some other company after we've installed the unit to them. Hopefully we're proud enough of the work that we've done that we want them to call us back should they have any problems. And I can tell you now that very few weeks go by where I don't get a phone call from an end user saying, we've got a unit, it was installed, but I can't remember who installed it. Can you recommend a company to look at it? And I think, wow, somebody's actually lost business here because they didn't put their name to the job. Right. We also expect you to explain the warranty condition, and that is for the installer company because you may be offering more or less of a warranty than I can offer. So you need to explain that to the end user, and also the location of the logbook and instruction card. Okay. And then also offer a possible maintenance contract. All right, so that basically keeps your foot in the door with the installation, so that the end user can always call on you to do the maintenance, and maybe you've got a proposed time that might be twice or 4 times a year, depending on the environment. Okay. And then before leaving the installation, clean up. Okay. There's nothing more exciting than to arrive on a site, okay, that's been brand new air conditioning system installed, and lying everywhere are empty cans of refrigerant, vacuum pump oil canisters, Coke bottles, cigarette stompies. Okay, and because the one thing that really drives us mad, okay, is when the caps are not placed on the service valves. Right, because Schrader valves, they need to be capped to stop them from leaking. There's always a small amount of refrigerant leaking from them, and over a period of time, this will have a negative effect on the system. All right. Guys, that's the end of that section. Are there any questions that you have about VRV installation, about what we've discussed this afternoon?
No questions.
I think, okay. All right, well then I'm going to say thank you very much. We've come to the end of this afternoon. It's a slightly shorter version or slightly shorter session than we've had in the previous 2 weeks, but I hope that it gives you an idea of what's required for you guys to get an all clear as we go through the commissioning. All right, remember that there is a process by which technicians can be accredited for commissioning equipment. It's quite an involved process. It's not meant to be easy. It requires technicians to maintain a high level of knowledge, to be regularly working with VRV. We accredit a technician within a company, and he's allowed to only commission their equipment. So it's not a method for you to moonlight on weekends, but it's definitely something that if you are growing with the product, that's something that you could consider. And it would be if you're a company that does a lot of VRV installations, and you need to be at least commissioning 1 a month, that we would encourage guys to have a go at and to see if we can get you accredited. All right, gents, thank you very much, and have a good afternoon further.
Thanks, Glenn.
Yep.
Okay, thank you.
Thank you.
Thanks.